Hello everybody, so welcome to our part 4 reflection of light by different surfaces. So in our previous chapter, in our previous video, we have discussed about the refraction of light. In that we have discussed some of the terms we call the pole, the principal axis, the center of curvature, the radius of curvature, focus, focal length, the object distance, the image distance, the paraxial rays and the marginal rays. So these are the terms which we have, marginal rays and the paraxial rays. So these are the terminologies which we have discussed in our previous chapter, and you have to remember all these terms, as these are very important not only for the exam point of view but also for the intermediate also. These are the basics which we need to learn in the optics. Okay, and next, how to calculate the focal length experimentally. How to calculate the focal length of the mirror. So let us do an activity over here. It is a small activity. So we take it as a V stand. So this is a V stand. So upon that V stand we have kept a concave mirror. So this is a concave mirror. So concave mirror. In front of it we get a screen, and beside that we kept a candle. So this is a candle over here. So what is the aim of this activity? This is a lab activity to find out the focal length of a concave mirror. So that is the aim. So what are the apparatus required over here? So the apparatus which we record is a concave mirror, a V stand, a screen and a candle. So screen can be taken as a white paper or a white cloth, whatever it should be in white color. So what is the procedure to do is, so first we have to fix a concave mirror on a V stand. It should not be moved. It should be in a fixed point. And next we take a candle. So this candle is considered to be as an object distance, and the screen we get an image of the flame on the screen, which is considered to be as a image distance V. So as we move, if we, for example, this is a V stand, this is the candle. So we have to move the candle. So we have to adjust a candle. For example, we can take it as at 10 centimeters. So the table will be U, V, and to calculate F. So that is U. For example, we take it as 10 centimeters and 20 centimeters, 30 centimeters and 40 centimeters and so on. So first for 10 centimeters, the image will be formed on the screen, or the image may be formed inside the mirror also. So for that we calculate the image distance. And at 20 centimeters we calculate the image distance. At 30 centimeters we calculate, 40 we calculate. And to calculate the focal length of the mirror, we use the formula, mirror formula, that is 1 by F is equals to 1 by V plus 1 by U. This is called as a mirror formula. So the derivation of this mirror formula will be in the next part. So to find out the focal length of a mirror, the formula 1 by F equals to 1 by V plus 1 by U is taken. So it can be written as F is equals to VU by U plus V. So it can be written as this, like this term also. So by using this formula you can find out the focal length of the concave mirror. Okay. So there is another alternate method. So what is the alternate method is, for a concave mirror, just place it in a sunlight. So if you place it in a sunlight, all the rays will incident on the mirror surface and they meet at a point. At that point, we get a bright spot. There you need to keep a screen or a paper. So after some time, if you can observe that the paper burns out due to more amount of heat energy falls upon it. So when all the light rays falls upon the paper, it gets burned out. So that point is considered to be as a focus. And the distance from the focus to the pole is considered to be as a focal length. Is considered to be as a focal length over here. Okay. So there are the two alternate methods. One is done by experimental method. Another one is by keeping in the sunlight. We get the focal length of it. And so this is how to find out the focal length of the concave mirror. And we have a ray diagrams for this. So ray diagrams will be considered to be as a next part. So before going to the ray diagrams, we would like to go for the rules for drawing the ray diagrams. So we need to find out the rules for drawing the ray diagrams. So that is we are going to discuss now. And whatever the problems that is here, that also we will discuss after that. And we need to find we need to follow the sign convention. So when we have to take positive, when we have to take negative. For the problem calculations, it will be an easy method. So that method will be remembered to you lifelong. It is very easy. Just while doing the problems, take a pen and paper, keep it with you. While doing the problems, you also do the practice, note down the important points, note down the sign conventions, so it will be easy for you. And even for drawing the ray diagrams also, take a pen, take a pencil, paper, compass, a rubber scale, whatever you need to draw for the diagrams. Keep all the things with you. And to draw the ray diagrams, exact perfect ray diagrams we need. So how to draw the ray diagrams also will be in the next part. So before that, let us see how to draw the ray diagrams by using sign conventions. We have some of the sign conventions here. Yeah, so for this is the rules for drawing the ray diagrams. So on the left side we have a concave mirror. These all belongs to the concave mirror. And on the right side we have a convex mirror. So what are the rules? Already I have told you in the starting beginning of it. Any light ray which is passing parallel to the principal axis, any light ray which is passing parallel to the principal axis will be passing through the focus. Or otherwise, any light ray which is passing through the focus will be passed through parallel to the principal axis. It's quite reverse. So, if a light ray is passing through the focus like this, if the light ray is passing through the focus, then it passes parallel to the principal axis. Okay, so this is the first rule which we need to know. Any ray which is passing parallel to the principal axis, it should pass through the focus. That is for a concave. So what it would be for the convex? Very simple. Any light ray which is passing parallel to the principal axis, it gets diverges as it is coming from the focus. That is, the ray which is being reflected, it appears to be coming from the focus. Or any ray which is appearing to fall on a focus, it passes parallel to the principal axis. Okay, so this is the very first rule you need to follow when drawing the rules, while drawing the ray diagrams. Passing parallel with the principal axis. So passing parallel with the principal axis, passing through the focus. Okay, so anything which is passing parallel with the principal axis, it passes through the focus. The same as reverse also. If it is passing through the focus, it passes parallel with the principal axis. Okay, so this you need to be considered. Anything which is passing parallel with the principal axis passing through the focus, passing through the focus, passing parallel to the principal axis. So this is the first rule which you need to follow, and this is also mainly used over here. And next rule is any light ray which is passing through the center of curvature, passing through the center of curvature, it gets reflected back to the same path. So this is the light ray which is passing through the center of curvature, it gets reflected back like this. So, okay now. And at the same time for here also for convex mirror, so this is appearing to be coming from the center of curvature. Any ray which is passing through the center of curvature, which is passing through the center of curvature, it gets reflected back and passes through the same medium. Okay, so this is nothing but which is act as a normal. Any line which is drawn through the center of curvature act as a normal. So when a light is passing through a normal, it gets reflected back and passes back to the same medium. So at that time the angle of incidence and the angle of reflection both will be taken as 0. Okay, and next any light ray which is passing along the principal axis, like this, either for concave or convex, it incident on the pole and gets reflected back. As we know that the line from the center of curvature to the pole is taken as a radius, so it gets reflected, it becomes as a radius of curvature, and also it becomes as a normal. So from the center of curvature to the pole, that is, it is also part of a curved surface, so it becomes a normal, and the line passing through the normal, it reflects back over here. And next, so maximum, these are the rules for drawing the ray diagrams. The very first thing you have to know is any ray passing parallel with the principal axis, it passes through the focus, or if it is passing through the focus, it gets parallel to the principal axis. This is the first one. Any light ray which is passing through the center of curvature is taken as a normal, and it also, when the light ray passes through the center of curvature, it reflects back. And any ray which is passing or incident on a pole, it reflects with the same angle. So here whatever the angle we are having, that is angle I, and here angle R, that is angle I and angle R will be equal. So for example, if we take over here, so this is the angle of incidence and this is the angle of reflection. This is the incident ray, this is the reflected ray, and the line drawn from the center of curvature is taken as a normal. Now the angle from the normal to the incident ray is taken as angle of incidence, and the angle drawn from the normal to the reflected ray is taken as angle of reflection. In this case, the angle I also will be equals to the angle R. So these are the ray diagrams. That is the rules for drawing the ray diagrams. You need to keep in your mind very carefully. The exam point of view, they may give the half of the diagram and you need to complete it. So for example, how they may give the half of the diagram is, so example, if I take this diagram, for this part, if I draw like this, and they will ask you to complete the diagram. So from this, if you see here, this straight line touches to the focus. That means it is appearing that it is going through the focus. So if it is going through the focus, it reflects back, passing parallel to the principal axis. So it passes parallel like this. So all the ray diagrams, once revise it. So these are very important to draw the rules, to draw the ray diagrams for concave and convex. So once make it clear, practice more, use a paper and a pencil, practice more and more. The more you practice, the more you become a perfect. So thank you. Let us move on to the another part of our reflection of light by different surfaces.